All right, welcome to the Explainer. There's this tool we all use pretty much every single day, and we probably don't even think about it. I'm talking about the URL shortener.
Yeah, you've totally seen this, right? You get sent a link, and it's just this monster of a web address. It's a mile long, impossible to share, and honestly, just plain ugly. But then you see the solution, that nice, clean, short link that just works.
So, how does that even work? How does this tiny little link handle the entire internet? It kind of feels like magic, doesn't it? But trust me, turning that absolute mess into a neat, clickable link is actually one of the coolest engineering puzzles on the web. So let's dive in and see how it's done.
Okay, first things first. Before we get into the nitty-gritty of how this all works, let's talk about why we even need it. Because, the advantages go way beyond just making a link look pretty. Think about it. Shortened links just look more professional, right? They don't break when you try to copy and paste them. You're way less likely to make a typo if you have to type it out. And honestly, they're just so much more convenient. But here's the thing. Making one short link, that's easy. Making billions of them, well, that's a whole different story.
And this is where we get to the real heart of the problem. This is the big twist. The challenge isn't just about shortening a link. It's about doing it at a scale that's almost impossible to wrap your head around, and doing it without ever failing.
Okay, so let's talk numbers. First up, creation. This system has to handle 200 million new short links every single month. Just let that sink in for a second. That breaks down to more than 76 new links being minted every single second of every single day.
And creating the links, that's actually the easy part. The real fire hose of traffic comes from people clicking on them. We're talking about a 100-to-1 ratio of clicks versus creations. That works out to a staggering 7,600 redirects every single second. And every single one of those has to feel instant. No lag allowed.
Right. And all of that data has to be stored somewhere, right? Over just 5 years, that's 12 billion entries. That adds up to at least 6 terabytes of storage. To put that in perspective, that's like thousands of movies worth of data just for tiny links. The scale of this supposedly simple tool is it's immense. So that's the real mission, isn't it? How on earth do you build a system that can handle that absolute fire hose of data without ever, breaking a sweat? It has to be always available, it needs to scale pretty much infinitely, and it has to be crazy fast. Okay, so now that we get just how monumental this task is, let's actually look under the hood. Let's see the blueprint. And it really all comes down to 2 incredibly clever tricks. So trick number 1. Every single time a new long URL comes in to be shortened, it gets a unique ID number. This number comes from a special component called a sequencer. You can think of it like a global ticket dispenser at a deli, but one that never ever runs out of numbers. This is what guarantees that no 2 links ever get the same short code. It's the absolute foundation of the whole thing. Okay, so you have this giant, unique number, something huge like 2 trillion and change. But how do you turn that into a nice, short, clean URL that you can actually use? That's the next piece of the puzzle. And this is where things get really clever. You might think they'd use a standard encoding system, maybe something like base64. But here's the problem. Base64 uses characters that are super easy to mix up. Think about the number 0 and the letter O, or a lowercase l and a capital I. So instead, they use a custom system called Base58. It's brilliant, really. It just throws out those 6 confusing characters to make the links way more human-friendly and less prone to typos. So, how does the magic math actually work? Well, it's actually pretty straightforward. You take that giant unique ID from the sequencer, then you just repeatedly divide it by 58. Every time you divide, you take the remainder. What's left over. Each of those remainders corresponds to one of the 58 characters they use: A to Z, lowercase, uppercase, and numbers 1 through 9. You just line up those characters, and boom, you've got your short, unique, and totally readable string. All right, so for our final section, let's put it all together and see how this really elegant design creates what is, honestly, a near perfect experience for us, the users. And this table just lays it all out perfectly. You want the service to be available all the time? Well, you use things like global load balancing and constant backups. You need it to scale forever?
You don't use one massive database. You spread the data out across lots of smaller ones. That's called sharding. Readability, we've talked about that. It's that custom base 58 trick. And latency, making it feel instant, that's all about clever caching, keeping the most popular links ready to go in super fast memory. But here is the truly mind-blowing part. Because that sequencer we talked about uses a 64-bit number, the system will not run out of unique IDs for, wait for it, over 7.6 times trillion years. No, that is not a typo. Trillion with a T. This thing isn't just built for the long haul. It's built for a future we can't even begin to imagine. So what's the big takeaway here? The next time you click on one of those tiny links, you'll know it's not magic. It is an absolute marvel of engineering. It's a masterclass in system design, built for massive scale and incredible speed, all to make our lives just a little bit easier.
And that's our explainer for today. It really makes you think, doesn't it? So we'll leave you with this final thought to chew on. What other simple piece of technology do you use every single day that might be hiding a whole world of complexity just beneath the surface?